The following scene will demonstrate how to use rapid motion and motion blur together. To recap about rapid motion is designed to tessellate the triangle using the minimum and maximum level as well as the actual threshold. So as you can see here, the actual minimum and maximum values are being set to -5, which is pretty low quality. In this case, because both have the same value, the threshold has no incidence or no usage. As I increase this value, there's a difference between minimum and maximum, then threshold can be used to better define the actual tessellation done by rapid motion to be able to better define. If you were to enable motion blur would use these triangles to smear it, and those triangles are basically containing constant information, constant color information, and it's going to cache this information and use it over time. So if you do have something that change color over time, chances are that this value will stay basically the same color as the opening shutter occurs, because these values will be cached. So let's go back to a preview quality level here. I'm going to set -5. If I enable motion blur here, as you can see, those triangles will get smeared as is without even getting refined or retessellated. So let's say, for example, I do increase the shading rates. I'll simply better sample these triangles, but it doesn't mean that this is a good quality. Actually, this is an incorrect render because there's not enough triangle or tessellation done by rapid motion blur to be able to do this motion blurring. If I go under the motion blur tab here and play with the sample threshold here, as you can see, there's no incidence because the actual quality is being defined by the actual shading rate. So in the case that rapid motion and motion blur are being used, the threshold has no incidence. It's really the shading rates being used. So as a proof, I'm going to keep this value as high as possible, which normally would produce a very poor motion blur quality if I were to use a scanline. So I'll keep it high just to show you that it's really not affecting the actual final image. Let's go back to -5, anti-aliasing. I'll first disable the motion blur, go back to anti-aliasing, and try to tessellate these such that we have a good approximation of the surface. The idea is that we don't want to set the actual rapid motion to over-tessellate or break up triangles so small that the actual motion blur will have too much work to do. So we need to find the right balance in terms of defining the surface such that motion blur approximate this result, because it's going to be blurred. So even though you break it up to have, let's say, 64 triangle per pixel, then obviously it's kind of overkill. So we really want to get to the point where we have a decent, rendered images static, and then once you activate motion blur, it's going to smear those pixels or those triangles without even adding tessellation. So in this case, what we really want to do is use this this value. So 0 means that to up to a maximum of 1 triangle per pixel, where -3 will be a triangle can be as large as about let's say 64 pixels, depending on the actual threshold value. So if I lower this, as you can see now, I'm starting to go more like towards 0, where this thing here is more like towards -3. So I'm going to lower this one, so such that I still see some visible triangles. So I would say I don't want these artifacts here to pop in, so I'm going to, perfect. This is exactly what needs to be smeared. That's a good surface approximation. So now I'm going to lower the actual shading rates very low, such that you can see the actual rendering is very fast, and go back to motion blur and enable the actual motion blurring. Now, as you can see now, I get this very noisy render, but quite well defined in terms of seeing the actual grid pattern being replicated here. Now I'm going to increase the actual shading rate to sample the actual moving triangle over time. So as you can see, increasing the shading rate will simply collect more sample as the triangle goes through a pixel. So let's say, for example, I've determined previously that a value of set 7, is probably quite adequate. I've been using Gaussian as a filter, so if I go back to box, I'll still get a little bit more dithering in the image. In this case, shading rate plus Gauss 3 should be enough to be able to resolve all these small artifacts. So in this case, I'm going to put it up to 8 and probably start to resolve some of the shadings. If you put it up to 10, obviously it's going to really look very smooth, but obviously that is going to actually affect the render time because there's more sample being taken as it moves. So it is really important. Once you have defined the motion blur speed and the actual sampling levels here, that you correctly set the shading rates, and shading rates will also affect the actual rendering time. Especially when motion blur is being used. If I lower this, for example, you'll see that the actual motion blurring is going to change totally. Now, because I'm changing the actual threshold, the actual tessellation is a little bit more rough than what it used to be. So these triangles are bigger and get smeared. So obviously we do lose actually some details in the actual render. I'm going to lower this one about this and see how this thing renders. And I'm going to lower the actual render. Here it is. That's it. I may put this thing, let's say for example I increase this to 0, disable motion blur, go to anti-aliasing, and use -1 0. The reason why I'm using -1 0 is because filters start to be effective and actually works only when the minimum level is -1. So if you're doing undersampling, actually no filters is going to occur. So if we set the Gauss, then obviously there's no message saying that filtering is incorrect. As you can see here, I did down there at the bottom of the screen here, it says that the sample filter was turned off and defaulted back to box. So I'll simply go back to -1 and keep the threshold really high because I still want to have a decent quality. So basically we'll go from -1 up to 0, which is pretty good. I'm going to go back here to motion blur and still get the noisy look that I used to get, and start to increase the actual shading rates. So up to 5, let's say, for example. If I go back to box, then obviously you see that box really filters out properly the actual samples. With these scenes, you'll be able to experiment with this feature and play with these parameters to see there's a fine balance between quality and time. Another thing that I forgot to mention here is that under motion blur there's a interpolate step. Obviously this will involves jittering the actual tessellated triangle instead of being a direct linear interpolation, but more or less a curve. So if I increase this, the actual grid is moving from here to here, but during its movement is also rotating by 90 degrees on y-axis. So that creates this very curvy motion blur here that obviously looks quite interesting. In this case, because a pixel is being smeared over a long distance, and obviously it is possible the shading rates might need to be increased to compensate for this very long distance traveling.